What is linear probabilistic modeling? In basic terms, the linear probability model is a form of a binomial regression model. This regression model boils down to the Bernoulli trial. The Bernoulli trial is described as a random experiment with only two outcomes, success or failure. Take a flip of the coin. The only two outcomes are heads or tails. But in our case of the linear probability model, it'll be a 0 or a 1. In this case, this sort of relationship makes it easy to fit the data to a simple linear regression. Take this scatter plot for example. We can turn it from this to this using the binary response model. Devore describes the generalization of the probabilistic model is to assume that the expected value of y is a linear function of x. However, the x value is fixed and y differs from its expected value by a random amount. Simple linear regression is using a method of least squares to fit a straight line model to the data at hand. Beyond this fitted line, there's also a random deviation or random error term that allows the points x and y to fall either above or below the fitted line to properly see the relationship of the data. And such a regression can show you the probability of what you're modeling because your binary outcome variable is equal to probability of whatever you're modeling. As for examples, a popular application of linear probabilistic modeling is mortgage loans. In this case, you can see how different factors such as ability to pay, income, and employment can affect just loan approval. Either it approves or it doesn't approve. As for engineering, it can be used to make predictions. If a company wanted to know the relationship between the cost and development of a product, they can use the linear probability model. And if they want to, say, use the linear probabilistic model to see a relationship between effort or work put in by the engineers and the quality assurance of the product they put out, they can do that as well. This is all just a number of factors that go into the approval of a project being greenlit or carried out. Either that or they will scrap it. So that's essentially what linear probabilistic modeling is all about.